Hello, good evening everyone. Today I am going to cover board questions on the chapter relation. In previous video I have go through theory parts of relation. Now today I am going to cover some of the questions from relation which is repeatedly asked in the board 12th board exam. So first question, given relation is AB such that A less than equal to B square. We have to prove that R is neither reflexive nor symmetric nor transitive. Solution. And R is, here set is given as a real number. Set is given as real number. So what happened basically, if I go for reflexive, then you can search for the pair AA. So here A less than equal to A square, which is false, because it is true for only A is equal to 1. It is true. But apart from that, if I consider fraction, suppose you can take 1 by 2 comma 1 by 2. So what happens for that? 1 by 2 less than equal to 1 by 4, which is false, because 1 by 2 is greater than equal to 1 by 4. So therefore 1 by 2 comma 1 by 2 does not belongs to R. Therefore R is not reflexive. So what we have to done always wrong thing, that we always consider for the like natural number 1, 2, 3, 4, 5. Since the set is the real number, so we can go for the fraction also, like 1 by 2, 1 by 3, 1 by 4. And there you can see that for the fraction, the reflexive relation is not satisfied. So this is for the reflexive one. Now for the symmetric. What is signature step for the symmetric? Let AB belongs to R. So this implies A less than equal to B square, but it never implies that B less than equal to A square. It never implies that, like if you say take see 1 comma 2 belongs to R as 1 less than equal to 4. 1 less than equal to 4. But what happened? Is 2 comma 1 also belongs to R? No, as 4 is not less than equal to 1. Therefore R is not symmetric. So symmetric, it is easy to show how it is symmetric. Always you remind that whenever you have to prove not, you have to give example. That's the way of writing the solution. If you have to prove, then there is no need of giving the example. But if question itself saying that it is not reflexive nor symmetric, non-transitive, in every case we have to put a pair or an example so that it satisfy your opinion. Now for transitive, third one, for transitive, let AB and BC belongs to R. This implies A less than equal to B square and B less than equal to C square as by the definition of relation. But is it implied that A less than equal to C square? No, which is false. So how can you frame a solution? How can you give the example? So let us take 2 comma minus 2 and minus 2 comma 1. 2 comma minus 2 and minus 2 comma 1 belongs to R as 2 less than equal to 4 and minus 2 less than equal to 1. But is 2 comma 1 belongs to R? This implies 2 less than equal to 1. False. Therefore, R is not transitive. R is not transitive. So in this way you can prove that this relation cannot be reflexive, symmetric or transitive. So you have to provide the example with necessary step. Now I am going to take some another questions. This question is asked in CBSE 2009. This is asked in question CBSE 2009. Now, next question. Second one. Set A is given as 1, 2, 3, 4, 5. Relation is given as AB such that mod A minus B is even. So prove that R is an equivalence relation. First part. This is the first part of question. Also, so that 1, 3, 5 are related to each other. Also, so that all the element of 1, 3, 5, all the element of 1, 3, 5 are related to each other, and all the element of 2, 4 related to each other, but one element of 1, 3, 5 is not related to elements of 2, 4. Question is slightly little bit long, but the concept is clear, no problem at all. So first of all, we have to prove that mod A minus B is even. This relation is an equivalence relation, and after that we can show that these three elements all together, like 1, 3, 3, 5, 1, 5, 5, 3, all the pair which is forming by the 1 3 pair related to each other. Likewise, in this set also 2 4, we have to prove that this is also going to related to each other. So we can start from the reflexive relation. How can we write? So first, for reflexive, since mod A minus A is equal to 0, which is even, therefore A comma A belongs to R. For every A belongs to set A, therefore R is reflexive. Now second, for symmetric, what is signature step? Let AB belongs to R. So mod A minus B is even. This implies mod minus of B minus of A minus B is also even. No change of any property. Or mod B minus A is even, or B comma A belongs to R, therefore R is symmetric. Therefore R is symmetric. Okay. If you say 1 3, the minus 2, the mod of minus 2 is even also. If you say 3 minus 1, again 2 is even, so it is also true. So by introducing minus sign, what we have to do, we change AB to BA, but the property is not going to change. So in this way you can think. What about transitive? So third, for transitive, let AB and BC belongs to R. So mod A minus B is even and mod B minus C is even. This implies mod A minus B plus B minus C is even, or A minus C is even, therefore AC belongs to R, therefore R is transitive. And before proceeding this, you can think over in your mind, if 2 is even, if 4 is even, so 2 plus 4 is also even. So why I am telling this? Because here I am adding. Why adding? Because if even plus even is even, that's why we are adding these two pair. Okay, so R is transitive, therefore R is an equivalence relation. Now, first part is completed. Now, how the element of 1 3 5 are related to each other? So, from 1 3 5, how many pair you can form? 1 3, 3 5, 5 1, 3 1, 5 3, 1 5, 3 5. What about 5 3? Okay, so 1 2 3 4 5, 1 1 also, 3 3 also, 5 5 also, 3 4 5 6 7 8. One pair is left. So 1 3 3 1. 1 5, 1 5, 1 5, 1 5 is missing. So these are the pair. Now see, in every pair the difference is even. In every pair difference is even. If you take 1 minus 3, then this is also even. 3 minus 5, it is also even. 5 minus 1, even. So every element of this set is related to each other, as our relation is A comma B such that mod of A minus B is even, and C, every pair of this set is satisfying this relation. Also about 2 comma 4. How many pairs we can form? 2 4 and 4 2. See, difference of this pair 2 minus 4 or 4 minus 2 is even. So this pair of this set is also satisfying. But when you take 1 3 5 and 2 4, now form the pair 1 2 1 4 3 2 3 4 5 2 5 4. Now see, the difference is 1, difference is 3, difference is 1, difference is 1, difference is 3, difference is 1. So it is not even. So it is not even. Hence the element of the set 1 3 5 is not related to the element of the set 2 comma 4. In this question, there are two parts. First of all, we have to put the given relation is a equivalence relation. Then later on, the element of 1 3 5 among themselves are related to each other, and all the pairs satisfy the given relation. That is true because the difference is even. Also, for the set 2 4, it is also true, but the element of 1 3 5 is not related to element of the 2 4 because their difference is not coming as even. So, okay. 2 questions are completed. Now come to later on. Next question. Question is, A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Are B relation on A cross A defined by AB related to CD is equal to A plus B is equal to B plus C. We have to prove that R is an equivalence relation, and we have to find the equivalence class of 2 comma 5. This is very famous question and also asked in the board of exam. And based upon this question, one question is also asked as AB related to CD such that AD is equal to BC. See, the sign of addition is replaced by multiplication. In the same way, we can proceed for both the question as we are. I am going to do this equivalence relation plus this relation. So see how it is equivalence relation. First, for reflexive. First of all, you think in the rough. You can do rough to write the statement. That is important. What is definition of reflexive for the paired set? AB must be related to AB. If you go through the relation, first is related to fourth, like A plus B is equal to second plus third, B plus A, which is true. Hence, the statement that I am going to form here, that since A plus B is equal to B plus A, therefore AB related to AB, therefore R is reflexive relation for every AB belongs to A cross A. So always plan in the rough work, then you can write. Now second, for symmetric. What is signature state for the symmetric? Let A be related to CD. This implies A plus D is equal to B plus C. Now here rough work is required. We have to prove that CD related to AB. So what is the rule? C plus B is equal to D plus A. C plus B is equal to D plus A. How can you write this using this one? We can interchange B plus C is equal to A plus D and C plus B is equal to D plus A. Therefore, CD related to AB, therefore R is symmetric. So always plan in the rough work, then you can able to write, because it is not easy to frame the sentences here. It is not easy at all. Now come for the transitive one. For transitive, third, we have to take two pair. So let A be related to CD and CD related to EF. This implies A plus D is equal to B plus C. This implies C plus F is equal to D plus E. Now put, if you see, the value of C from here is D plus E minus F, and put the value of C here. So A plus D is equal to B plus D plus E minus F. So DD cancel out, F coming by transposition, F coming this side, it becomes A plus F is equal to B plus. If you see exactly in the rough work what we required, AB related to EF. And if you go through the rules, so A plus F is equal to B plus E. That's what we are getting. So this, therefore AB related to EF. Therefore R is transitive relation. And likewise, all R is equivalence relation because it satisfies all the relation. Okay. Now, equivalence class of 2, 5. We have to find the equivalence class of 2, 5. So as the definition of equivalence class, one pair we are knowing, and we have to search other pair. We have to search other pair so that 2 plus D is equal to 5 plus C, the rule. Or 2 minus 5 is equal to C minus D. Or minus 3 is equal to C minus D. Means the difference of the element of the pair must be. We have to search C or D such that the difference of the element in the pair must be minus 3. So we have a set A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, so take 1, 1, 4. 1 minus 4 is minus 3. See, 2, 5. See, 3, 6. See, 4, 7. Then 5, 8. 6, 9. These are the equivalence class of 2, 5. See, in every pair, for the every pair, the difference is minus 3. So equivalence class of 2, 5 is this way. And that's all today. 3 questions, very popular question. Thank you for watching.